Lovely. Hello, WarsawJS. Can you hear me? Oh, yeah. Whoa. Looks like everyone had enough pizza, if you ate enough pizza and beer and all the things, like whatever floats your boat. Anyway, I'm going to be talking about front-end tools. That's stuff like bundling, compiling, transpiling, whatever else. You cannot escape it in the modern front-end world. And this is going to be a small history lesson on how we got to what we have right now in the ecosystem. And yeah, that's my name. Unfortunately, I just learned that I'll be speaking 3 hours ago. So I no longer work here. You can disregard this place. And before, the corporate office would call me and say, oh, you have to say that everything you say in this talk is of your own and own opinion, does not represent an opinion of the company. But good news is that now I no longer have to say that. I no longer work there. Woo! Anyway, by the way, I'm up for hire. I am cursed. Whichever team I join in any company, I end up working in debugging, bundlers, looking at bundle analyzers, debugging performance and stuff like this. And with this particular talk, I'm also cursed because the last time I did this talk, I broke both of my hands, and I had to perform it like this. But anyway, let's go back to the very beginning. Is this audio a bit echoey, just for me? Fixed? All good? I think they're off. Small technical break. Well, yeah, you can't have it. Yeah. It's off. All right. Anyway, let's go back to the very beginning. But hello? OK. But not this far. Not this far. Yeah, the prehistory. And at the beginning, there was Web 1.0. It was as beautiful, and that was simple. You had just HTML and maybe a bit of CSS now and there. Then in 1994, this guy gets tasked like, hey, can you create a language that will add some sort of interactivity to our web pages? And by the way, you have 1 week. And he was like, yeah, and this is how JavaScript was born. And in the next era-ish, we have the ancient history. This is where the Internet Explorer is dominating the browser market. And we have the Web 2.0, and all the logotypes are now shiny. We have interactive websites that are able to, we have stuff like Ajax, which is now you are able to update the content of the page without reloading it, which is magical. And we have jQuery. jQuery comes to save the day in the browser wars, if you remember this. And naturally, as in any historical period, then we have the Renaissance. And if you ask me, let's say in something like 2010, 2012, like, hey, what do I need to learn in order to become, a front-end engineer, a client-side developer? I would say, oh, it's really easy. For styling, we have stuff like Sass, less stylus, CSS and JS just came out, CSS modules. Oh, by the way, no one uses JavaScript. You need to have CoffeeScript, Flow, LiveScript, Hegel, TypeScript, BriefScript, ReasonML. There's a bunch of stuff. Oh, yeah, you need to somehow run and bundle all this stuff. We have Bower, Gulp, Gunt, NPM, Yarn, Babel. And yeah, you need to test this stuff. You need to, there's just so much stuff. And all of this is really complicated and big and bloated and yada, yada, yada. If you remember this pain, you remember this pain. Anyway, and all of this runs on your very own miserable computer. You start up a new project, you run NPM, whatever, and it just explodes. It's so slow. And if it's not running on your computer, it is, of course, running in the cloud, aka someone else's computer. And it costs money, of course. Right, let's take a look at typical-ish 2020 front-end release pipeline. Anyone here still uses Webpack? Just 3 hands? That's four-ish hands. That's.
People don't know they do.
Oh, okay. We are that upper level. All right. Anyway, Webpack is a tool. All right, whatever. Let's take a look at the typical 2020-ish front-end release pipeline. That all starts with the code change. Let's say we create a pull request to change our code. First of all, we perform type checks. We use TypeScript as good developers should. We perform type checks and generate type definitions. After that, we take our code and transform it into a target output. This is where tools like Babel would come in, and they would transform modern JavaScript without the TypeScript into something that runs in all the browsers that we want to cover. Then we run bundle reliant tests, like end-to-end tests, let's say. And of course, we need to test stuff. We have test code, which is, of course, TypeScript tests. They need to be transpiled to JavaScript, then be run. Then we have some sort of linter. And if everything is green, we can deliver our code change to CDN. All good. Let's take a look at now an app that I used to work in 3 to 4 years ago. It's a big monorepo app. It's around 1.5 million lines of code. And the first step, which is just running TypeScript and emitting type declarations, was 3.5 minutes. Transforming the entire app took 6.5 minutes. Transforming tests was 4 minutes. Running tests, we had a lot of tests. There was 45 minutes. And code quality and lint could take up to 15 minutes. And the end-to-end test, which is the whole user flow and application spun up and done, that was like 1 hour. All right. Then let's talk about the modern history. This is why we are all here. And I'm not sure what about you, but I'm super excited about everything there is now and what's to come, but more on that later. Anyway, so all of those tools that we have or used to have right now were written in JavaScript by JavaScript developers. I'm not saying that those are bad tools, bad language, or bad developers. These are brilliant engineers. We're standing on the shoulder of giants. But just somehow down the line where we realize that, it just does not scale. JavaScript on a bigger scale is slow for how we use it. Maybe we just are not good enough as engineers. Anyway, but some people realized, what if we just take the same stuff that we have right now and just rewrite it in a language that is just marginally faster? It's a language that compiles to native binaries, and it's faster. Right. Anyway, this is my fictional division of tools that you will not find anywhere on the internet, hopefully. So I would divide everything that we run in our code in our code base into 2 parts. That's going to be conventional tools, which is stuff like Webpack or Vite that just calls all the other tools sequentially, maybe in PM runners or whatever. And foundational tools. This is something that are individual kind of binaries that you run. Tools like ESLint or Babel. We run them separately, right? Let's talk about foundational tools of the new era. First, we have the 2 big brothers. And these were developed by roughly at the same time. This is where there was a COVID pandemic. And all the cracked engineers were locked at home. They had nothing to do. They just rewrote the good stuff in, well, we'll talk about it later. Anyway, SVC, which is Speedy Web Compiler. It's a really stupid name, in my opinion, but it's a really nice tool. It's written in Rust by Dong-Yoon Kang. It is very fast. It can bundle with some limitations. It can minify code. And it is developed in a way that is more open to feedback and community focused. So let's say, like, if you open a PR, if something is wrong, you open a PR and say, I want to fix this, and it will be accepted or denied. And then there is ESBuild, which is ECMAScript builder. And it's written in Go by Evan Wallace. It is fast, can bundle with some limitations, can minify it, but it's more a single person focused. So this guy just says like, I want to have a fast bundler and minifier and compiler. I will just build it for myself. And if you don't like how it works, well, good luck. I'm not accepting or your changes, your opinions don't matter. So I guess like those are the benchmarks that are from, I think, at this point, they're like 5 years old. So it's pretty old. But they're just here to show the orders of magnitude, how much ESBuild, SVC are faster than just TypeScript and Babel, which is insane. The amount of time saved that you can have is incredible. Right. So this is the slide again from, because everything is in JavaScript ecosystem is moving really fast. And it's this 3rd time I'm doing this talk. And I don't have the time to update the slides because everything is changing. Anyway, so these were the 3 points of those 2 tools that were kind of downsides, right? So there is never this existing community support for problem solving, extending this stuff because everything is new. No one knows how to solve problems. And both of those tools cannot bundle reliably. It just doesn't work yet. and the benefits of adoption. So, I need to change my code somehow so it can be bundled by these beautiful tools in hundreds of times faster. It might be not comparable to the effort. But now, there's probably just one problem left, that still bundling is a hard problem and is still not solved in those two tools. Right, anyway. In the app I mentioned previously, what we did is we replaced Babel with SVC. And what we got is 6.5 minutes down to just 2 minutes, which is 3 times improvement. Then transforming test code to target output is now 3 seconds, which is insane. And yeah, it got marginally faster. Just by, basically, it was a drag and drop replacement almost. Anyway, let's talk about the next foundational tool, which is Lightning CSS. If you use something like new CSS syntax, if you use Sass, or if you use less, you probably use something like autoprefixer or post CSS. And this is that, but faster, written in Rust by someone I will mention later. Anyway, and of course, if you're using something like Tailwind or Next.js, I think this is an old Next.js logo, and I hope Vercel will not sue me. You're already using Lightning CSS if you're using Tailwind or Next.js, most likely. And all right. Now, this little thing is JavaScript oxidation compiler. And for now, it is just a linter. I'm just going to show this benchmark here, and I'm going to come to this back later again. Yeah, you can see it's crazy fast. Right. Now, conventional tools of the new era. The big engine combiners that combine everything. Anyone knows what it is? Yes, Vite. This was the first revolution of in the bundling world because, yeah, anyone knows how Vite works and how it's different from Webpack? No? Well, exactly. Yeah. Just a quick, this is an ugly picture from the Vite docs. And this is your traditional development server for something like Webpack. You start bundling, then the module crawler goes all around your module tree and just compiles everything. Then you have a bundle, and then your web server is ready. But with Vite, the server is ready as soon as you type the command, and it goes only to the modules that are requested. Like, it bundles as soon as you request something, which is crazy. And I'm going to show a small demo here. Hope it works. Oh, yeah, of course. And you're going to ask, what about the new modules? Like, you don't bundle them at runtime. And the new modules are bundled in advance by ESBuild. That's what makes it really fast. Anyway, okay, there's still no demo. Sorry, it's been a while since I did this talk. Anyway, so the Vite is currently still using rollup under the hood when you are doing production bundle. This is how you can escape those problems I mentioned before, that in production, we still don't have a reliable way of bundling in the same way that we did before. So bundle could be slightly bigger, slightly different. The minification could be different. The tree shaking might not work or something else. This is why when you're doing a production build with Vite, it's still using rollup, which is a battle-tested bundling solution. And yeah, the developer experience is crazy good that I will demonstrate in just a second. Yeah. So as I was saying, on the left, Vite is already done, and Webpack is still compiling. This is just a random app that I picked up. It was using Webpack by default, and I just converted it to Vite quickly to demonstrate. It's crazy how good it is. Yeah. Now, next thing, when I was doing this talk for the last time, this just came out. So this is an Rspack, which is a one-to-one port of Webpack written in Rust, which is insane, which means that you can just take your Webpack, convert it, replace the binary with this, and it will just be faster, right? And it has a whole set of tools like Rsbuild for libraries, bundle analyzers for design systems, whole set of tools. Since then, I didn't have the time to explore it, but I met a person who made it, who was a team leader for Rspack on the conference, and now I can't wait to try it in something else. Anyway, let's plug Rspack into our actually real app that we did that too. So the bundling, the transforming the source code and bundling from 6.5 minutes, we got down to 20 seconds. This is, again, 3 seconds, and Yeah, so it's already gotten so much faster. Right. Now, you might, this is Parcel. Anyone ever used Parcel? This is like us. Yes, Parcel team. Good. I really love Parcel. This was the only thing like, oh, I don't know how to set a Webpack. What do I use? Yeah, just use this. It works out of the box. You don't have to set anything up. And you ask me, why is it here? It's not new, it's old. And these guys were like, yeah, we don't want to jump onto the bandwagon of fast stuff. So what they did is first, they developed Lightning CSS. Lightning CSS is developed by people from Parcel, and they use SVC as a plugin, is the replacement for Babel, basically. So right now, if you want something that is very fast and works just out of the box, you can use Parcel. Now, the fun stuff. This is roll down. This is called roll down, and this is, as you might have guessed, fast Rust rewritten roll up. So it used to be roll up, and they are rewriting it to be roll down in Rust. And why? That is because, as I said earlier, Vite is using roll up under the hood. And what they want to make is their own version of rollup, which is, of course, going to be open source, and it's going to be fast. Yeah, written in Rust. Still, I think this is the slide from September, and it's no longer early in development. Now you can actually touch it and use it and run it, and it works. And yeah, and build with OXC, this is what I mentioned before, that, oh, wait. OK, I think I'm going to talk about this later. Anyway, and this is the Warsaw dream. Anyone knows what it is as well? Yeah, that's Rspack. And this is something that we got. This is a dream of Warsaw that they tried to sell us for a long time, but it's still nowhere to be seen. You can kind of see it in Next.js. You can use it in Next.js, but it's like, yeah, we don't know how it works. But the basis and the concept is that you cache stuff. You do less work, and you save more time by caching output of like singular functions and files. And if you say like, okay, this file is compiled and has the same output, we'll keep working on it. So it is long and complicated history, and I don't even want to sell it to you. But what I want to sell it to you is, yes, but I don't know how this is related. It's not actually ROM tools, it's Biome. It is also a long and complicated scandal in the JavaScript ecosystem family because it was set to do bundling, compiling, documentation generation, formatting, linting, and so much more. Minification, of course, yes, type checking. Everything has to be there, but now it is just code formatting, nothing else. Why is that? OK. Let me tell you why I'm so invested in this dream, the Biome dream. Let's see what do we do for the majority of our ecosystem runs, code base runs. So for everything that I will divide everything in like 3 categories. So code enhancement, that's TypeScript or transforming JSX, for example, to JavaScript. Code quality, that's ESLint and Prettier, for example. And code delivery, which is bundling and minification. It's going to be Webpack and Cursor. So all of those tools roughly do the same 3 things. First thing we do is we parse the AST. We transform the text into abstract syntax tree, which is how we are able to perform operations and transforms on it. After that, we do some kind of calculations on the AST that we've generated. So we check if it's a valid syntax, if it's the right formatting. We detect assets and traverse the module tree. And then the result, we do whatever we do. It's failure pass, produce bundle, whatever. Can anyone spot here is the thing that we might want to improve? Yes, sir. Exactly. This is the dream of Biome. One AST for everything that saves up at least 4 times, but probably much more time than that. That if we have one united AST to rule them all, the world would have been so much better. Right. Yeah. So code formatting for Biome. Let's take a look. Going back to our real imaginary application, we've replaced our up to 15 minutes running of ESLint and Prettier to 10 seconds. Look at that. That's insane. Anyway, with all those tools that we have, why do we still live like a renaissance? Why do we still burn our resources and sanity on old stuff. It's up to you. Anyway, so we got down from 25.5 minutes to 33 seconds in total of our entire application. And that is, it sounds impressive, but in reality, it's 46 times faster, 750 minutes per day, 375 hours per month, per year. So it's roughly $2,000 saved per year, which is nothing for most big companies, right? But what is priceless is developer sanity and happiness. This is much harder to calculate, and this is what we want to save by upgrading all this stuff, right? Anyway, the Biome dream, since the company lost funding at some point and now are slowly picking up pace with being fully open source and unpaid, but the dream lives on because Vite, and as I mentioned before, the roll down and OXC, which is, I said, just a linter, now they want to expand. So OXC is not just a linter, it's a tool that produces that one AST. And it can also do, like, it generates AST, and then it does the code formatting and linting. This is, oh yeah, I just said that. Why is it even here? Yeah, it's resolver, minifier, blah, blah, blah. So this is going to power roll down. It already powers roll down. And roll down is powering Vite. I know I'm sounding like an insane person with this. There's a meme of a guy showing up stuff. Right, so the ES build and rollup are going away from Vite, and everything now is on OXC and roll down. Everything is fast, and this is the dream of Biome, because now formatting and linting is going to be shared. The AST format is going to be shared between bundling and linting. And this is all going to be in Vite. And how do I know it? Now it's not a surprise, actually, because it's already revealed. But I asked, oh, no, it's not here. Anyway, I asked the guy who's developing OXC compiled. He told me this, and there was a huge reveal on the conference. Anyway, the future. Let's talk about the future. Potential speculations, whatever else. Why do we build and bundle in general? Why do we need that? And because browsers do not understand the code that we want to write. They don't understand TypeScript. They don't understand a lot of cool new syntax. And network overhead is a thing. If there's this there's a person who's preaching the no build. Oh, yeah, there's a slide on it in the future. I keep saying that. Yeah, cache invalidation is hard. If you just have your normal JavaScript files and with no hashes, nothing like this, you could have a hard time by your bundle being cached in the client. Anyway, we might have solutions to all those problems in the future. So when the first time I did this talk, I tried to, I generated all the images with, I think it was Midjourney at that time. It was really shitty. It was just when it appeared. But now I tried really hard to generate a person with 3 arms, and it was just always giving me 2 arms instead of 3. So I'm proud of myself. Anyway, import maps. This is already implemented, so you can already use it. It's not such a distant future because it's already available. And for those who don't know, is the code you would write usually in your day of work, you would import something from a thing. But if you put this into ES module and give it to the browser would never understand what is leftpad, what is deep equal, where are those files? How do I get those modules? And this is why we have import maps that are if you're importing from leftpad, you're importing from this file. And this is how you can have stuff like this in the browser without bundling. And this can also be used to control hashes, to selectively invalidate several files in the bundle. And this is really powerful. And there is a person, as I said, called GHH, who is preaching the no-build dream. And if you want to live the no-build dream, you can set up the latest Ruby on Rails, and you're going to have no-build dream by default. But it's not that simple, because we have HTTP. HTTP has something there is a problem called head of the line blocking. This is a problem that we used to have in HTTP 1, where we could not stream several requests at the same time. But with HTTP2, we can do that. But still, there is a problem. Like this problem comes from the TCP level, because TCP is really TCP has really strict congression control, and it says like, oh, this one packet is dropped. Let's wait until it's retransmitted and pause everything else. And we cannot get rid of that as long as we are using just our standard HTTP2. But with something that people called HTTP3 or quick, we are no longer going to have this problem. And this means that you can use just no bundle, straight up hundreds of JavaScript files going to be streamed to your device. Even if you change connection from Wi-Fi to mobile network, it's still going to not interrupt it. And this is amazing. I'm not a big network guy, so I can't really. You can Google it yourself, right? We don't have much time. Now, the big scary thing, TypeScript, is, by the looks of it, not going anywhere. And the same person who made SVC made, that was what, 2021, made an attempt to fix this, like to actually take TypeScript runtime, TypeScript compiler, and rewrite it line by line in Go. This person is insane, I'm telling you. And of course, he never succeeded. And there was, this is the person who made OXC. I talked to him on Twitter in DMs, and he told me that he tried it, but the problem is just, it's a funding problem. Like it's just so much work, and no one is willing to invest into it that it's just never going to happen. So if you're working in a big company who wants to sponsor this, please do. Right. Of course, then there is proposal type annotations. Let's have something like TypeScript in the browser. And that is the fourth most start proposal. It is stage 1, so it's years to be implemented in the browser. We'll never go, probably in the foreseeable future, we're never going to agree on how actually we want to have types in the browser. And it's really, of course, controversial and contested. People say, oh, no, you can't do this. You have to do it like this. And if you read the TC39 transcripts of the meetings, people argue for hours on how it should be done and never agree on anything. Anyway, and this is the one they had to write like 2 hours ago by hand. Now, in Node.js, we already can leave this no TypeScript dream. If you run, I think it's a flag, experimental strip types, you can straight up run TypeScript files with Node.js with no extra setup and steps required, which is very good. That actually uses SWC under the hood. Right, so in the future, we will have no bundling and everything will be super fast. So we never know what's going to happen to TypeScript. Transform, nothing to transform, no bundle, and everything is going to be amazing. I'm looking forward for this bright future. And oh yeah, almost forgot. With all those fast tools that we have right now, and I know I already said that you should switch instantly, but please do not forget about the shoulders of the giants we're standing on. Please, if you have the time and the funds, please do support all the other things like Babel. They're doing the great foundational work. The post CSS, the Webpack is still very important to keep afloat. Anyway, and with that in mind, I thank you for. I hope I didn't take that much time, and yeah, thank you. We have no time for questions, I guess, but.
I was just going to give you good news. We have plenty of, we have one question, one lucky question. Wow. There was an absolutely fast hand right here.
There was like a quick draw.
Wait for the box. You're going to get a box. You're going to blue box. No, over here. Front row.
The person, yeah.
Who wanted? Okay. So thanks for the talk. It was very interesting, really exciting news. Not all the tools I've heard about, so some of them are very popular, some at least maybe I haven't checked for a while. So yeah, really great. Thanks a lot. Just curious, so one of the slowest steps in your pipeline were tests. So yes. I mean, you were still optimizing for the build time, which was not as slow as tests. So I'm just also wondering why you didn't try maybe monorepo with like incremental builds where only affected things would be tested, builded, deployed, and so on, and maybe like micro front ends, but maybe not. Let's not touch.
That's a really good question. We used to have that. I mean, okay. So first thing first, I was working in a team that was responsible for all this infrastructure stuff, but I got fired, so I can't really tell you. There was an effort to, like, we did have incremental builds with the NX. So NX was responsible for figuring out what changed and only running those tests. But I didn't have the chance to finish it, so who knows?
Okay, thank you.
Thanks so much. Once again, big hand round of applause. Mikhail, I love.
Thank you.
Warsaw.